Okay, hopefully this is the last video and we've only got a few pages left to go. Alright, so we're going to find a solution to the following equation if one exists. Show the work that leads to your answer. So the first thing we do is we look at our denominators and we recognize that x plus 2 should not equal 0. And so if I look at my denominator and say, okay, x plus 2 is equal to 0, subtract 2, subtract 2. So the first restriction on my domain is that x cannot equal negative 2. If I make it negative 2, then I'm dividing by 0, and then horrible things happen. So then what I'm going to do is I'm going to cancel my denominators and try to solve this equation the old-fashioned way. So what I need to do is I need to multiply both my left and my right by x plus 2. So I have this cancels with this, leaving us with negative 6. Now I have 3x, and I have plus 1 times x plus 2, which, nicely enough, distributing 1 is child's play. So now we've got negative 6 is equal to 3x plus 2, which is the same as 4x plus 2. And then I subtract 2 from both sides. So now I've got 4x is equal to negative 8. And x, by dividing both sides by 4, is negative 2. However, since I just figured out that x can't be negative 2, and yet my solution is that x is equal to negative 2, I have arrived at a contradiction, which tells me I have no solution. If, however, you put that x was equal to negative 2, you were algebraically correct, but your final solution was wrong, which is unfortunate. Okay. For your next point, for your next one, this is on a scale of, I believe, 1 to 2 or 1 to 3. So this part right here is going to be your y1, and this part right here is going to be your y2. So the first thing you want to do is graph your constant line. So here's your origin point here at 0, 0. And you're going to go up 1, 2, 3, 4. And so, may not show up that well because it's black on white, but let's see if that works. Okay, so there's our first one. Then we need to map our intercepts and our asymptotes. I know that my degrees are the same, and so I know that my horizontal asymptote is going to be where y is equal to 1. So I'm just going to make myself a couple of dotted lines where y is equal to 1. Then I have a vertical asymptote where x is equal to positive 4. So I go 1, 2, 3, 4. Okay. Then I'm actually going to plot our little function. Now I also know that I have a 0 value at negative 2. What I'm going to do is I'm going to just go on ahead, turn my calculator on, and I'm going to plot x plus 2 divided by x minus 4 in my first equation. And my second equation is going to be that y is equal to 4. And I'm going to take a look at that graph. Now I'm not just going to eyeball this sketch. I'm going to see, first of all, where the two of them intersect. So I'm going to just say, okay, second and trace, although I don't need to use the trace, but that's okay. Intersection. I'm going to let this be my first curve. I'm going to let the other one be my second curve. I'm going to see where they intersect, and lo and behold, they intersect at x equals 6 and y is equal to 4. So that tells me something. That tells me here at 1, 2, 3, 4, 5, and 6, I have a point right here where x is equal to 4. That's one critical point I really need. Now, I'm going to go to my table and see if I can find any other critical points. As you can see, I have a 0 at negative 2. And then let's see where else I've got some nice integer points. I've got a y-intercept of 1/2. That doesn't help me much. I've got a point at 1, 1, or 1, negative 1. And I have a point at 2, negative 2. And I have a point at 3, negative 5. So here we go, 1, 2, 3, 4, and 5. All of these I get from the calculator. Now, After that, things stop getting integral, except where x is equal to 5 and y is equal to 7. So here's 5, 1, 2, 3, 4, 5, 6, and 7. Negative 6, or positive 6, here I have 4, 7 you got 3, and then 2.5. So here we're off 1, 1, 2, 3. And now that we have some good integer points, we're going to go on ahead and complete our curve. Rather than just eyeballing it mindlessly, we can actually make our curve look pretty nice. Ooh, pretty curves. And that is how one should have handled it. What I was looking for is I was looking for our point of intersection, and I was looking for our constant line, and then something that looked like what I was looking for. Okay, let's take a look at 15. 15 was remarkably interesting, evil, and simple. You're looking for the domain. To find your domain, you take a look at your denominator. Well, your denominator, you have to find where x squared plus 9 is equal to 0. Well, if you subtract 9 from both sides, you now find that x squared is equal to negative 9. And if you tried to take the square root of both sides, you find all of a sudden that x is equal to plus or minus 3i, which tells you that the only restrictions on the domain are not in the real set, and rather that it's all real numbers. Okay, let's take a look at 16. So here we've got the graph. If the graph is translated 3 units to the left and 3 units up, what's a reasonable domain for the new function? Now, if we're moving it 3 units to the left, because we remember our x is an insider, insiders lie, that means we're going to add 3 to that negative 5. And then the fact that you're going 3 units up means you're going to add 3 as a constant. So, you're going to add 3 here, and you're going to add 3 here. So your new function is going to be y is equal to 2 over x minus 2 plus 3. This tells me, because, going back up here for a moment, 3 minus 5 is negative 2, and the 3 that's a constant is going to remain outside. So then that tells me, here's my new function, now we need to see what fits. This tells me I have a vertical asymptote at x is equal to 2, and I have a horizontal asymptote. Because my degree of my numerator is less than my degree of my denominator, my horizontal asymptote should be 0, except I'm adding the constant 3. So this then says that my domain is everything but positive 2, and that my range is everything but positive 3. Now, let's take a look at our functions for a moment. Hey, domain is a set of all real numbers except that x does not equal 3. Well, that's wrong because we know x does not equal 2. X does not equal 5, doesn't work. X does not equal 3, still doesn't work. X does not equal 2 is the only one that fulfills both conditions, and that's it. Just by finding the domain, if properly done, you can eliminate the other wrong choices. Okay, let's take a look at 17. It's asking you for reasonable domain and range of the situation. Now this is a real-world situation, so you're not going to have negative things. Water is added to a 50 milliliter solution that is 50% acid. The equation represents the concentration of acid in the mixture as the amount of water is added. So we're looking for the reasonable domain and range. What we would actually do is we would think about this as 15 divided by 30 plus x. Now, before we go to the graph, let's go to our window. Obviously, we're in the first quadrant. So let's just say 0 to 20. Let's just say 0 to 20. And you will notice that it flat lines out. So actually, let's actually zoom it in a little bit. Let's say from 0 to 5, scale factor of 0.5. Do you see how even with the enhanced scale factor, it dips and gets smaller and smaller? So, that tells us our domain is that x is greater than 0 because you can't add a negative acid. Could include 0. And our range is that y is less than 1/2, but greater than 0. Because you notice we start at 0.5 here, and then it gets lower and lower. And that's pretty much all that there is to that one. Now, for number 18, they're asking for the Johnson family amusement park thing, discount package, unlimited number of rides, will charge an entry fee for each person. The equation below is the cost per person as the number of people in the family, which of the following statements is true. Family ticket price costs $120 and the entry fee is $7.50 per person. Could be true. I like it, but let's take a look at the other choices. Family ticket package costs $7.50 and the entry fee is $120 per person. Well, we already know that $7.50 is a constant. In this one, whereas this one, wherever you see the word per, it's a little confusing. The equation below is the cost per person, which means the $7.50 is a sunk cost, the $120 is not. So we know that's wrong. If 6 people use the family package, the cost would be $9.50. Let's try that by plugging it into our calculator. So we'd actually do clear 120 divided by x plus 7.5. Well, we'll go to the table and evaluate the function at 6. Well, if 6 people use the thing, it is clearly and obviously not $9.50. So that's wrong, mathematically incorrect. And let's take a look at D. If cost is $19.50, then there are 12 people in the family. Well, let's go down. 11 and then 12. And once again, the numbers don't match up. So even if we're not terribly good at reading, we can actually punch the numbers and see that C and D are clearly and obviously wrong. So the correct response was A. Okay, let's take a look at 19. Automobile's velocity starting at complete stop, which is where time is equal to 0, is measured in feet per second. What happens is the velocity increases. Now, this is actually a simpler problem than anybody gives it credit for. They're essentially asking you for the horizontal asymptote. In this case, the degree of the numerator and the degree of the denominator are both 1, so your horizontal asymptote is y is equal to 140 divided by 5. Well, 140 divided by 5 is 28. And so the velocity at some point will level off at 28. Now, even if you're not terribly intuitive when it comes to this stuff, you can actually just plug it in and take a look. 140 times x divided by 5x plus 3. And I'm going to put some parentheses just to be certain, although I do not believe that they are necessary. Okay, now we know we're not going to see it right off the bat. So what we're going to do is we're going to go to our window again from 0 to, let's just say 0 to 50, and from 0 to 100. And the scale factor is going to be 1. And let's take a look. And you see that it levels off, and let's see where it levels off to. Let's go on ahead, hit trace at 50, and you see it gets very close to 28, and so 28 is as high as it goes. So it does not continue to increase, it does not continue to decrease, it does not approach 140. In fact, it levels off at 28 feet per second. The last one, most of you got right. Basically, it's trying to tie at 50%. So starting off, you have 9 out of 21 games. You could actually do it by iteration, which is the easiest way to go. If they win a game, it becomes 10 out of 22. If they win another one, it becomes 11 out of 23. And if they win a fourth, it becomes 12 out of 24, which is tie. And so the correct response was 3 wins. And that's it for this. All right.